question that I want to ask you guys about these boards?
Are they all the same? Or is it different?
Which ones are different?
That's right. What is the same about them and what is different about them? Yes?
Yeah.
Molly?
Well, it seems that some people have different times than others, like finishing times. So some have 3.5 and some have 3 seconds.
That's actually kind of interesting.
Yeah.
So you have 3 seconds here. What do you guys have?
We had 3.5, but our last data point we didn't like. So we got rid of it.
So you threw it out?
Yeah.
We did all
Threw it out.
Sounds about right. Okay.
Yeah.
We did up to 3.5.
3.5?
Why are they different?
Oh. Actually, that's a really good question. Why are they different?
Well, did everyone start with 0, 0?
Yeah.
Oh,
They Audrey pointed out that she said, how many books did we start with? Because I know we started with like 4 books, and then we're like, okay, that's too fast for us to catch, so we put down to like 2 books.
That?
Oh, that's interesting, right?
Yeah.
Okay, let's keep that in mind. That may come back for us. Okay, Kaylee, did you have a comment or a question?
Yeah,
Loudly.
how come some of them, like theirs is like a perfect curve, but most other ones are kind of like, there's a little curve at the
Because I graphed it right.
Did you guys all understand her question?
Yeah. I think that those are just like connecting the points where you're supposed to draw the best fit line. So it's supposed to be more like smooth instead of dot, dot, dot.
Yeah.
It's just human error, I think. Like on the computer, I'm pretty sure they're all the same based on the fact they're all quadratic.
Yeah, they all are quadratic.
All right, Tommy, nice and loud.
They don't seem to follow a quadratic track.
Okay, so this is what Fran said, and then Tommy echoed this. He said they all look to be quadratic. True or false?
True.
True.
What gives you that impression, though? All right, don't hide. Say it nice and loud, Connor. Does the curve look like a quadratic?
Yeah.
All right, so maybe the curve looks like a quadratic. That's what he said. Go ahead.
When you look at the equations, they're all like x squared or something like that.
Okay, was it x squared?
Or it's a variable squared, so it's t squared.
Okay, so you guys,
Squared.
so you had t squared. Did everybody get t squared?
Yep.
So there's a relationship somewhere that we're gonna try. You're trying to analyze a relationship. Is that what you're telling me?
Right.
All right. So if it's quadratic, let's try to get involved with what Megan said. If it's quadratic, should we see some sort of pattern in your data table?
Yes.
Okay. If it's quadratic, should we see a pattern in your data table?
Yeah.
So let's do this. Like, for example, if we look at this, hold up so we can see it. Does everybody have at least 1 second on their data table?
Yeah.
Does everybody have at least 2 seconds on their data table?
Yeah.
So going from 1 to 2, this is like times 2 in the time, true?
Yeah.
If it's quadratic, then we should be able to predict something happening in the position, yes?
Yeah.
All right, so I want you to check your group on this one. Okay, check your group on this one. If you double the time, what do you expect, based upon its quadratic, to happen to the position, and how closely does your data resemble that? Check your neighbors now, quick.
Yeah. 1 and 2 is 5 and 1.
All right, so are you guys, are you good with quadratic?
Yes.
You sure?
Yes.
Okay, that's fine. I don't care. But if you guys are good, then we'll go with it.
I mean,
Okay.
your opinion does matter, though.
No, it doesn't.
Yes, it
No, I don't.
does.
Okay. All right, so that's great. Good job. So what else is the same? What else is different? So let me ask you this then. Oh, you have a question?
Yeah, I was going to say something else now.
Oh, jump in.
I noticed that, I mean, well, it's kind of a given, but we all went through the experiment the same way, and pretty much everybody took down the data the same way, so we know it's consistent.
All right, so something that's the same is since we all use a very similar procedure, are you surprised that we got similar results?
No.
My question, and Jamie, I'm going to come back to you in a second. My question is, since you pointed it out, I want to focus in on it. When you look at this, do you think we were all supposed to get the same coefficient and we're just off by some small amounts? Or do you think there was something different about the way that you guys structured it that would have led to different? Before you answer me, check your neighbors. All right? Do you think they should have been all the same, or do you think they're opposite? question, there were some hands up. Does someone have a comment? Mr. Red?
I mean, well, it depends on the books.
What do you mean?
Like, the size of them, like, we use like 2 like small books, but I'm seeing like a huge binder over there that's like really thick. And they stacked it like a stack of papers on them. So it's like, they can be different than ours and stuff like that.
Okay. Someone want to add to, anyone agree with Mr. Red? Oh, a lot of people agree? Yeah.
We were the ones with the binder and the giant stack of paper, but ours was only, our coefficient was only 0.15.
All right, one at a time. Emily, go ahead.
I think it would affect like the speed going down because like if you're at a higher rate, you'll go down faster. But I don't think it will actually affect like any like data.
It's gonna stay however many.
Okay. Over here? Yeah, or somebody. Somebody had a comment. I want to make sure we get to it. No? Follow-up comment to Emily's?
I agree with everyone.
She read.
Well, there are 2 different opinions out here.
I'm confused at mine.
Well, originally someone said, or Mr. Red said, it's the number of books dictates the coefficient. And I'm going to kind of infer, I think what you were saying was the number of books changes the coefficient. Yes?
Yeah.
Did you kind of imply that like the number of books would change it in a certain way?
I was just thinking like it would just change like the more books you have, like the faster the cart will go down. That's what I was thinking. So like, you know, yeah, someone help me out.
Jump in, Jamie.
I can test what Jeffrey said. We started out with 3 large physics books, 4, and a binder. So we like, okay, we're just gonna let it go, and we could not keep up. So we actually lowered it and because it just was going too fast, and like we couldn't keep up fast enough with it. So if we left it at that, probably the coefficient would have been higher because it was racing down so fast that we could barely even keep up with an accurate measurement.
Okay.
Yeah.
What? Margot?
She asked if the coefficient is the speed.
Like, I guess then wouldn't we all need to know what the coefficient actually means?
Yeah, what is the coefficient?
Yeah, what is that velocity? Is
Wouldn't
it?
it be the change of velocity over time because the velocity not staying the same as time goes on?
Okay, so Taryn said, does it have to do with like, is it the change in the velocity over time? Because what he said was the velocity is changing as it goes down, true?
Yeah.
Right. Was the speed constant as it went down?
No.
No, it's not.
So what's the coefficient?
I don't know.
Oh gosh.
What do you think it is?
At first I thought it was speed, but now
This
it's
is
not.
acceleration. It's acceleration.
Okay. So is acceleration a term that you guys have heard before?
Yes.
Is it a term we've talked about in here?
No.
Okay. Yes.
I think the coefficient is just a way to figure out where the position will be at a certain time. So if you plug in, let's say 1 for t, so if you square 1, still 1, multiplied by 18, and it should be there at 1 second.
But
So, I
then
mean,
like,
it's a little off, yes, but
so what does it mean then if someone has a smaller coefficient than someone else? Does that, like, is the smaller coefficient faster or slower?
the smaller coefficient would be slower because when you multiply it by something, a large number times something will be bigger than a smaller number times something.
You know, I have a question I think might help us understand this a little bit. Let's try to relate it back to our data table and see. So, did everybody's ball or car, however we did it, get at least to 2 seconds?
Yes.
Okay, I want to know how far each one went in 2 seconds. What's the position of each of your objects at 2 seconds? Okay? Well, let's hold on to this as an idea. Is that cool? Can we hold on to this as an idea? Yeah. You want to do something hard?
No. Are we going to have to find the velocity?
We are, but that's the easy part. We're going to do something hard first.
I thought that was...
Here's what I want you to do, okay? I want you to work with your neighbors, work with your group, and I want you to see if you can find some units, you know, like meters and seconds, some sort of combination of those meters and seconds, for your coefficients, okay? Work with your neighbors, work with your group, see if you can find the units for your coefficients. Okay, anybody agree with Audrey's assessment of that? Anybody disagree?
We just wrote it different.
I have a question.
Go ahead.
If you did though like centimeters times centimeters over sorry, centimeter per second times second over, would it cancel out by centimeters? Or is it over second squared just on the bottom?
It's not?
Yes, it is. Centimeters per second.
You're saying, we're saying per second, so it's being divided, where they're saying second times second. But that's, I agree with that.
Oh, I see your question. She says is, so centimeters, so per means divide, right?
Yeah.
We decided that earlier in the year.
Yeah.
So you think centimeters per, and then you have second squared in the bottom?
Or, yeah, or is it centimeters
per second.
per second times a second?
So it would be like centimeters over seconds, those in parentheses and then squared. Or is it? Like, you have to, I'd have to do
Write
second
it
squared.
down.
Yeah, write it out.
She's right on the board. Takes control.
Therefore, those would cancel out, it's just centimeters.
It's the first one.
It's the first one.
Oh, Andrew, you thought it was something
Yeah, I
different.
thought it was
completely.
different.
Yeah,
I
I don't think,
I thought you were
I
talking
read my
about.
version.
yeah.
Yeah, I know, I understood your version. Well, I'm in a situation.
Wait, put the or.